we're now looking at factoring trinomials. So x squared plus bx plus c. So what we'll notice is that they're trinomials, so there's going to be 3 terms until there isn't, but for the most part here there'll be 3 terms, and they will be x squared, then x, then just a number. So c is kind of like just a constant number. And so we are going to factor. There is a bunch of different ways on how to factor, so I'm just going to show you how I do this, and I do it kind of like a math puzzle. So just as a reminder, factoring is where we turn it something that's predominantly adding or subtracting. So right here I'm taking these 3 terms and I'm adding them to each other, and I'm going to be changing it to something that's multiplied. So 2 things that are really multiplying. So I'm hoping to turn it into where things are being multiplied. That's what I mean by to factor. Now, before we were taking GCFs out, this is a completely different thing. So let's just keep in mind here that you might not get it the first time, and you might not like this method, in which case there are other things that you can look up, or someone can teach you a different way. The reason that I teach this way is because later on, it'll be a little bit easier to understand how things work. So things get really complex, and this method will always work for all of them. So what you're going to do here is you're going to these left 2 boxes are going to need to multiply to the left side. So what things multiply to x squared? That's really easy because x times x gets me x squared. Then the right 2 boxes here, these have to multiply to get to 6. Now I think of 6 times 1, or I think of 3 times 2. Now, it's almost always the numbers that are closer together, but it's not always the case where it is. It's almost always. So for the sake of it, I'm going to choose the opposite. I'm going to say 6 times 1. So 6, and I'm trying to get this little dot here. Yeah, so 6 times 1. So now the left 2 boxes multiply to the left, and the right 2 boxes multiply to the right. The way to now check to see if you've done this correctly, because that's easy, we're just guessing. The way to check is to multiply the diagonals. So this diagonal, if I multiplied those together, I'd get a 1x. 1 times x is 1x. If I multiply that together, I would get an x6, but that looks weird, so I just write 6x. And then if you were to add those 2 together, you would get 1x and 6x. Those are like terms. You can add them to get a 7x. And the idea is this term the same as the middle term? Clearly it's not. So that tells you that you need to redo this puzzle. So I'm not going to do 6 and 1. As I said before, it was a 3 and a 2. So let's try that. Let's put the 3 and the 2 here. Now, just to confirm, x times x, the left side still multiplies to x squared. 3 times 2 still does multiply to 6. So I've done that correctly. But now I do my diagonals. So I have a 2 times x, which is a 2x. 3 times x, which is a 3x. And if I add those together, I get a 5x. And sure enough, that's my middle term. So I usually put a little check mark here. So that means that my factors are here. There's an x. There's no symbol here, so it's going to be an x plus 3. And then the other one's an x. There's no symbol there, plus 2. This is fully factored. I have now factored this thing. Now, that's where you stop. But just to ease some doubting minds, let's say I multiply this in x times x, x squared, x times 2, 2x, 3 times x, 3x, by the way, 2x, 3x, 2x, 3x, those are the ways where I got those, and then 3 times 2 is 6. Now you can add like terms, 2x and 3x is 5x, and then there's a plus 6. This is my original equation. So if you multiplied your factored form, you would be able to get your original equation as a way to verify. But that's not what we're asked to do. We're not asked to verify. It just says just to factor. So again, we're going to do a bunch of these, and I'll try to go through them slowly, but eventually we're going to go through them really, really, really fast. So let's just try the next one here. I need to create this box. Oops. Okay, and the left side needs to multiply to the left. So that's, for us, it's almost always going to be x and x. But I mean, this could be a y squared, in which case this would also be a y, and then we would have to go y and y. y times y would be y squared. So keep that in mind. So x and x would be x squared. Now I've got 8. Well, that's 8 times 1 or 4 times 2. Now I said it's usually the ones that are closer together. But just to show you what happens if you choose the wrong one, well, in which case do the right one, but 1 times 8. Now the left side multiplies to x squared, beautiful. 1 times 8 does multiply to 8, also good. So then you do your diagonals. 8 times x is an 8x. X times 1 is a 1x. If you add them together, you're going to get a 9x. That is not my middle term. So I know, okay, that's wrong. I'm going to just erase it here and try it again. So let's try 4 and 2. Again, x times x is x squared. 4 times 2 is 8, so the left multiplies to the left, the right multiplies to the right, and my diagonals. X times 2 is a 2x. X times 4 is a 4x. So if you add them together, you just get a 6x, which is what we need. That's our middle term. So from there, we can go like this. Now that we know we've verified, we've got an x plus 4 and an x plus 2. Now keep in mind, you don't actually have to multiply, when you do these diagonals, you don't have to just use the x. This is also considered a 1 in front. 2 times 1 is 2. 1 times 4 is 4. 2 plus 4 is 6. And you can just look at the numbers. You don't even need to have the x. Now I'll keep writing the x, but it's not actually necessary. So let's try this again here. Let's try the next one. Okay. X times x. The left boxes get me the left side, which is x squared. 2 times 5 or 5 times 2, doesn't matter. In fact, let's take a look here. Let's try 2 times 5 or 5 times 2. So my left side multiplies to my left. My right side multiplies. 2 times 5 is 10. And my diagonals, that is a 5x. That is a 2x. And if you add them, you get 7x, which is my middle term. And so that works. Let's try this one. X times x is still x squared. 5 times 2 is still 10. But my diagonals, x times 2 is a 2x. X times 5 is a 5x. And if you add those together, you get a 7x, which is my middle term. So either way, this will work. Both times you get 7x. So what do we have here? Well, we've got the top here, an x plus a 2, and then here, an x plus a 5. And I'll put a box around that. And if you did it this way, well, then you would just have an x plus a 5 first, and then an x plus a 2, which is the same thing. It's just a different order. That's like saying 2 times 7, well, that's 14, but 7 times 2 is also 14. So order doesn't matter when you multiply. So I wrote down both. Again, doesn't matter to me what you do. Okay, let's try 2 more. Or 3 more. Let's just take a look here. X times x gets me an x squared. I have a 12. So that can be a 12 and a 1. Now it has to be negative, so one of them would have to be negative, I don't know. Or I could have a 6 and a 2, or I could have a 4 and a 3. Now I said choose the numbers that are closer together, so that would be that. But part of me is taking a look at the numbers already. Is there some way with a 6 and a 2 that we can get 4? It's like, well, yeah, 6 minus 2. Is there any way with 4 and 3 to get 4? It's like, well, no. 4 plus 3 is 7. 4 minus 3 is 1. So you're trying, I'm always looking at that middle term, trying to be like, is there one of these where I could add or subtract some of the numbers to get 4? And so I immediately see, well, 6 and 2. So let's do 6 and 2. Now, let me just erase this. 6 and 2. The left side multiplies to x squared. X times x is x squared. However, the right side doesn't work. 2 times 6 is positive 12, and I need a negative 12. So I need to put a negative somewhere, and I don't know where, so I'm just going to put it right here. And then you can just verify. Same way we've all done. Always done it here. X times 2 is a 2x. X times negative 6 is a negative 6x, and if I add those together, I get a negative 4x. That's not what I have. I have a positive 4x. So what you can do in this case is just change the spot where the negative went. So I put the negative up there, but there's no reason. I just put it there. I'll put it down here. So again, x times x is x squared. Beautiful. 6 times negative 2 is indeed negative 12. So the left multiplies to the left and my right multiplies to my right. But do my diagonals add to the middle? So I've got a negative 2x. X times 6 would be a 6x. And if we put those together and if we added them, 6 and a negative 2 would be a positive 4x, which is what I have. Again, you can think about the numbers if you wanted to. Just do that. Negative 2, there's a 1 here, so negative 2. Multiply the numbers here. 6 times the 1 is 6, and if you add them together, you get a 4, which is my middle term. So you don't have to include the x's there. So this works. I get my 4x, so I have this, and I have this. I have an x plus a 6, and I have an x minus a 2. Okay, let's keep going here. I also have a 12. Okay, so I mean, obviously the left is x and x like it almost always is, but then I have a 12. And again, that's 1 and 12, 2 and 6, and 3 and 4. So I'm putting a times table, times in between, because I need to multiply to 12. And obviously one of them needs to be negative. But I'm looking, the number right here is a 1. So I'm just looking, if I was to go 12 plus 1 or 12 minus 1, is there any way that I can get 1? It's like, well, 1 plus 12 is 13. 1 minus 12 is a negative 11. So I'm looking at 13s or 11s. 2 and 6, I mean, we did that last time. 2 plus 6 is 8. 2 minus 6 is negative 4. And it's like, there's no way we can get 1. But then I look at 4 and 3, and I'm thinking, oh, 4 and 3, if I add or subtracted those, yeah, I can go 4 minus 3, and I can get 1. So when I'm doing this, I'm going to go, okay, well, 4 and 3, and I did 4 minus 3. The negative went with the 3, so I'll put it there just to see. Let's just take a look here. That's just my best guess. So I take a look. The left side multiplies to x squared, x times x, yep. The right side, 4 times negative 3 is indeed negative 12. Okay, that's perfect. And the diagonals, I can, again, just look at the numbers. There's a 1 here, so 1 times 4 is 4. 1 times negative 3 is negative 3. If I were to add those, I would get a positive 1, which is what I have, a positive 1. So that works. I'll keep working here with just the letters, but I have a 4x and a negative 3x, which will get me a positive 1x. So yes, that does work. So let's take a look here. I got an x plus 4 and an x minus 3. Those are my answers. This is now in factored form. Okay, let's take a look here at one more. All right, let's try this again here. So left side, x and x, get me an x squared, 18. So I'm thinking, okay, well, 1 and 18, 2 and 9, 3 and 6. I think that's it, 4, 5, yeah. And so immediately I'm looking at these, is there any way I can get 7? It's like, oh yeah, 9 minus 2. That is how I can get 7. And those multiply, so 9 and negative 2, those multiply to negative 18. Okay, so let's just give this a shot. This is me guessing here. So x times x is x squared, perfect. 9 times 2, negative 2, is a negative 18, perfect. So now my diagonals, again, if you were just look at the numbers, there's a 1 here, so you get a 9, and that number is a negative 2, but I'm going to do the way I've done here. So x times 9 is a 9x. X times negative 2 is a negative 2x, and if I add those together, I get a 7x. Perfect. So that is 1, and that is 1. I have an x plus a 9, and I have an x minus a 2. All right, so that's how you do that. We're going to do more in some other videos in the next ones. There's plenty of more to practice here. There's just tons. And so there's a lot to go through. There's probably 2-3 more videos here. And they're all done in this exact same way with this grid.